Hey y'all, it's your math teacher, Mr. Boyden, and welcome to the introduction to my statistics course. Today we're going to be looking at some of the basics of ways of displaying data. We're also going to see some ways that these representations can be misleading or even lying. We're going to see lots of examples of that. So today's lesson is called Analyzing Categorical Data. Okay, categorical is the sort of the counterpart to saying that something is quantitative. So up here I have this question: can numbers be categorical? Normally we think of numbers as representing a quantity, like you have 3 apples. It's just that's a quantity, not a category. But actually numbers can totally be categorical, which might be surprising at first. But like, for example, when you dial a phone number, what do you dial first? You probably dial an area code, is my guess. That area code is a category. It's saying a category of people fall into this area code. So area codes are categorical. Another example is zip codes. Like we live in the 98407 zip code. Like it's not 94,000, or the 98,000. It's not like that. It's not a quantity of something. It's just a number that's assigned to a group of people. So in that sense, the numbers are describing a category. So a resounding yes, they absolutely can be categorical. So yes, all right. What we have here on the left is basically just a list of the things we're going to go over today. It's all the things we're going to talk about. So frequency tables, relative frequency tables, bar charts, histograms, and so on. I'll let you read them. So let's get right into it. In order to do this, we need some data. I'm going to use some data that I collected from one of my classes the other day. I asked them, what day of the week is your birthday on this year? And by that, I really meant like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So let's look at their responses, and then let's use this to understand a few different things. First is a frequency table. Okay, a frequency table is very easy. So here it is. Frequency table. All it is it's saying for Monday, none of my students have a Monday birthday, so I guess we're going to have sad Mondays this year. Tuesday, I had 1 student with that. I had 1 Wednesday birthday in my class, 4 Thursday birthdays in class, 1 Friday birthday, 3 Saturdays, and 3 Sundays. Okay, guys, that's a frequency table. That's all that is. What about relative frequency? Okay, relative frequency is no harder, although it looks like it at first. So the relative frequency of a Monday is 0. The relative frequency of a Tuesday is 1 out of, I think there were 13 responses. So 13. The relative frequency of a Wednesday is 1/13. Relative frequency of Thursday is 4/13. 1/13. 13th. 3/13. And 3/13. Now, let's make a note here about what the totals are. So in total, the total of all my frequencies is the number of students who responded and gave me data. So that is 13. The total of the relative frequencies is 1. Now that should give you a clue about the different things relative frequency can mean. That suggests, and this is true by the way, that it's basically the same thing as a probability or a proportion. Probability. All right, so it's a probability or a proportion, and so that can be super useful too. All right, bar charts and histograms. One thing I want you to know about histograms have to represent frequencies, as opposed to bar charts, which can represent lots of different things, and we'll see some examples of that in just a minute. But histograms specifically have to be frequency, just so you know. Let's look at a bar chart. And we're going to look at 2 different kinds, and they're both going to represent the exact same data set. So one question that you might want to think about as we go through these things is, how do we communicate data in the world? And how are data communicated to us? And are the ways in which they're presented designed to inform us, or are they designed to mislead us? And that's one of the things we're going to talk more about in just a minute. But these 2 have the exact same data set, okay? And notice over here, it's a percentage. That's the reason why this is a bar chart, not a histogram. It would have to be frequency to be a histogram. And this is talking about people in the environmental club and whether they own a snowmobile, rent a snowmobile, or they never have used a snowmobile. And so we can see the data here, and here they're stacked. We call this a segmented bar chart. And notice both of them go to 100. So I wonder what you think is a more informative way or an easier way for you to understand the differences. Yesterday when I asked this in class, a lot of the students preferred the one on the left. I actually prefer the one on the right. And the reason that I like the one on the right is it's really easy for me when like these two greens are side by side. It's really easy for me to see that one's a lot bigger than the other. Same with the blues. It's really obvious to me that one is quite like about double the other one. So my preference is the right, but if yours is the left, it doesn't really matter. It's just a matter of preference. Let's talk now about some misleading graphs. This is one of my favorite things to teach in stats, to be honest with you, because it is so relevant. It's not the kind of thing that we test on, but if you go through the world with your eyes open to misleading graphs, you will start to see them all over the place. Okay, here's our first one. And guys, what I want to encourage you to do is when I put one of these graphs up, pause the video and see if you can tell why it's misleading. I'm going to go pretty quickly through these, but seriously, pause them and take a really good look at them. Okay, this first one is super messed up. Look at this. According to this graph, if you glance at it, it's showing that this bar for Drake is way bigger than for, uh-oh, my age is showing. I don't know how to say that, guys, and I'm afraid to guess. But look over here. You're looking at 21 million versus 20 million. So they're really close, but it doesn't look like it the way this is presented. This is what the graph should actually look like. And you might think, wait, how do they get away with that? Well, a lot of times, especially on like our TikTok and YouTube generation stuff is only on your screen for a few seconds at a time. So all you're going to see is you're going to go, oh, Drake, big bar, everyone else, small bar. Wow, Drake's killing it. We don't always have time to really break down the information. Let's look at some more. Here's another one. This graph is a true graph of average annual global temperature in Fahrenheit. But it is misleading though. If you glance at this graph, this line looks like it's flat. It doesn't look like it's trending upward. And so someone could put this graph up and say, see, global warming's a hoax, temperature's flat. Look, it's not even going up. Well, actually, if you zoom in a little bit, a different trend is visible. You can see back in 1880, the average temperature was around 57 degrees. And you can see a little bit of an upward trend up to where we're now up to about 58.5. And it turns out that 1.5 degrees in terms of global temperature is a really big deal. So that first chart was true, but it's misleading. And that's something that's really important to understand in statistics. You can cite a true statistic or give a true representation of the data, but it might not be clear communication and it might not be honest communication. Isn't that weird? Something can be true but not honest? That might be something that you haven't thought about. This graph is true, but it's not exactly honest. I'm thinking like if I presented this to my parents, they'd think I was lying. So kind of interesting. Okay. You can do the same thing with stock charts. Here's an example of Twitter. And in this one, you can see that Twitter was low and Twitter shoots way up and you think, wow, Twitter's doing great. It's up in 3 months. Like Twitter's on the rise. But if you zoom out, and this is only a 3-month period, if you zoom out and look out over the long term, you can see that actually Twitter's been going down for a long time. It was over 60 at one point, close to 70, and now it's at $18. Yikes. So the two stories here, the first story is, wow, Twitter's on fire, it's coming up. And the second story is, wow, Twitter's going down in flames. Which one's true? Well, I guess it depends on what you're looking for. But one important thing to see is that you can use the same data and tell two completely different stories. And that's something that we need to be aware of anytime we're having data tell a story to us, is what data were used and why is that? Because, for example, the data might be cherry-picked. Here's an example that was shown on TV recently. Okay, and so they have the approval rating for President Trump at 88%. And usually they'll put a graphic like this on the screen for a few seconds. They even did a good job down here of citing their source, which is great because then you can go look up the information if you want and verify it. That was an NBC Wall Street Journal poll. But then in print up here, this was only among Republicans, which is kind of like saying the people who support President Trump support President Trump. So maybe it looks like he has this high approval rating, What's the truth though? So I pulled the data from this actual poll, and if you look at all the data in the poll, not just the data that look like they're approving, this is what you get. You get that 29% strongly approve, 16% somewhat approve, 8% somewhat disapprove, and 44% strongly disapprove. Well, that's a very different picture than what was presented on the TV. And so it's a situation where, sure, you can go look up the data if you want, but for people that aren't looking deeper into the data and trying to understand it, and this is all they get, they may end up with an inaccurate picture of what's really going on. Here we have a chart that is from the year 2012 that was set to be released by the Republican side of the Senate Budget Committee. And it's giving some information here. And this one is really interesting. Sometimes you have to zoom in on data to really get a clear picture, like with the climate data. And sometimes you have to zoom out to really get a clear picture. And that's one of the things, it's not always clear cut. But doing one or the other, since they tell different stories, can be used for different purposes. In this one, if you glance at this chart, what you probably see is a strong and dramatic upward trend. And what are they talking about here? Over 100 million people in the US now receiving some form of federal welfare. A chart like this would probably be used to say, wow, the welfare recipients really is something that's rising right now. It's really, really dramatic. But what happens when we look at the scale? This is down here around 97 million. And this is here at, looks like it's about 106 or 107. Okay, so 97 to 107, that's 10 million people, but it's about 10 or 11% increase is all. Does this bar on the right look only 10 or 11% bigger than this first bar? Not really. So if someone's not really digging into the numbers, what they see is, holy moly, this is 3 times higher. Things really are out of control. Really, we're having some tough times. Okay, versus if you look at the numbers, you see that it's rising, certainly, but not as dramatically as the chart would have you think. Okay, we have a similar issue right here. This chart is comparing 35% against 39% or 39.6. But what is this bar? Maybe 5 times more area than the first one? That's misleading. A more accurate graph would be this one. Okay, if you actually graph the numbers. Now, is this one lying? No, it's not. This is true. It's absolutely true. But if it's only on your TV screen for a few seconds and you don't really dig into the numbers, you might get the wrong idea about what's going on. So we're not calling them lying graphs because it's not a lie. They're just misleading graphs. All right, here's another one. I pulled this one off of a TV show that I was watching. In this one, the graph just doesn't mean anything. I mean, there's no axis labels. I have no idea what the size of these bars mean. I don't think they mean anything, actually. So this one's not a graph, it's just a picture. What about this one? This is one that I took a picture of when I was watching TV. This was only on my screen for about 2 seconds. I had to go back and pause it in order to take this picture of my screen. Okay, the issue on this one, they're presenting, it looks like it's supposed to be a normal distribution. But we know that normal distributions are symmetrical, and this graph clearly has symmetry. And yet, it's saying that the center of the graph is at 770. And the left is at 148, and the right is at 4100. Well, that's not even kind of symmetrical. That's wildly skewed. So that's not an accurate graph. This is another example where that's not a graph at all. That's a picture. Now, I did say that this section was going to be about misleading graphs. However, there are times when graphs are out and out lying and wrong. And this is a case of lying. Okay? Take a look over here at the right. And they have the actual data, but notice the graph doesn't match the data. So over on the right over here, they've got 9% and 8.6%, and they're at the same level. What's up with that? Last I checked, 8.6 was a smaller number than 9. Or look at this. This 8.6 is higher than 8.8. No, that's not how graphs work. That's not reasonable, okay? If you graphed it out accurately, it would look like this. It has a big old dip at the end, and that's by far the lowest point of any of the data on the graph. So what gives? Why is this happening? Well, this graph is of the unemployment rate under President Obama. And if you are a news source, you probably either want to say that things got better or that things didn't get better under President Obama. It looks to me like since over here, the graph would have gone lower, and lower unemployment rate, most of us would say is a good thing, they're trying to hide that fact that the unemployment rate went down from the beginning of Obama's term until this moment in Obama's term. Hey, a pie chart. So this is a good chance for us to talk about pie charts and what they have to have and what they have to not have. There's a bunch of issues with this chart. First of all, a pie chart has to add up to 100%. That's not optional. You don't get to have it add up to more, and it adds up to like 200 something here. So no, this is not a valid pie chart. The other thing we could point out is the largest number on this chart is 70, but does that red section look like the largest slice of the pie? Not even close. Look at where the center of this chart is. Does that look like it's the center of that circle to you? It looks like it's elevated to me. And it looks like maybe they tried to make a 3D model that tilted. But the problem is, it looks like this back Palin section is much smaller than it is. And actually, to my eyes, this 60%, which is the smallest number, that looks like the biggest region. So that's kind of a lie too. This one is really pretty dishonest. This pie chart has similar issues. First of all, it's not even in percentages. The other thing is, over here, the largest number on the chart is 69, and it does correspond to the largest region. But look how big that region is compared to 47. To my eyes, it looks like it's 4 or 5 times larger than the 47 region. That's not accurate. So both this one and the previous one, they're really not graphs or charts at all. They're really just pictures. And someone's trying to make some sort of a case with it that is not an accurate case. Here's another one that's really misleading. And this one is another case where it's true, but it doesn't tell the story that it's supposed to. Okay, this is talking about gun deaths in Florida and the number of murders committed using firearms. So what they have down here is that they had a stand your ground law enacted. Now, if you glance at this chart for 4 seconds, what you're going to see is that they have the stand your ground law right here, and as we get closer to the present day, things are lower. Okay, and you got 721 over here. And so you go, okay, great, stand your ground law and gun deaths are down. That's awesome. However, look over here. What's going on over here? This graph is upside down. It's not facing the right direction. So at this point, it looks like there's just over 500 gun deaths. And actually, every year since they enacted that law, there's been more gun deaths. There's been more than 600 every single year. So whether you have this chart right side up or right side down, or upside down, you can tell different stories. If it's upside down, you can argue really quickly that, hey, look, gun deaths went down. Isn't that awesome? Or if you have it the correct way, you would be showing that gun deaths went up. Okay, so this one is, boy, it's misleading. It's not dishonest because it is the real data. But again, most people, when they look at a graph, they're not very discerning. They're not going to think critically and look for problems. They're going to take what they see at face value and go, oh, okay, cool, I understand this now. So that can be super dangerous. And this is something that you as a student in this class, you can learn that, hey, I can be really honest with data and I can communicate correctly and I can call out when people are being dishonest. Or you can go the other direction. You can mislead people and you can lie to them. I hope you're going to fall on the honest side and on the side of good. Because knowing the truth is important and it's valuable and we can make things better when we know the truth. So that's where I hope you will land. Two-way tables. These are just tables that summarize values between two categorical variables. What we mean by that is the variables are not taking on all these numeric values, they're broken up into categories. So here's an example. In the following table of column relative frequencies, read that as percentages, by the way, these are percentages. They show data on the 2012 United States Senate election and incumbents. Out of all the election participants, there were 23 incumbents. I'm going to make a note of that. There's 23 people in this category. And so here are the categories. There are the ones who won and the ones who lost. So that's one category with two different values. So that's one variable, okay? Because it's whether you won or lost. And another variable is whether you were an incumbent or not. And we have two categories or two variables, or excuse me, two values for that variable as well. So variable number 1, variable number 2. So it is a two-way table. Let's answer the question below. How many incumbents lost their re-election race? So incumbents lost. That's here in the table. but they didn't ask what the relative frequency was. They asked how many of them lost. So remember, that relative frequency is like a percentage. 0.043 is 4.3%. So we know that 4.3% lost. That's 4.3% of the 23 incumbents. So we're going to do 0.043 multiplied by 23, and that tells us that there was only one incumbent who lost. In order to learn about our last 4 topics today, which really are all very closely related, we're going to use these data in this table. These are the same data from the beginning of the lesson. We looked at the segmented and side-by-side bar charts, but here we have the actual table for it. I want to encourage you now to pause the video and get this table down in your notes, because we're going to be using these data throughout the rest of the video. So let's answer some really basic questions about the table. First of all, how many students go to this college? The grand total, 1,526. How many have used a snowmobile? All right, own a snowmobile. It might seem like it's 295. That's actually not quite right, because it didn't ask how many own a snowmobile. It asked how many have used a snowmobile. And I want to argue that if you've rented a snowmobile, then you probably have used a snowmobile. So we actually need to add those together. So 574 plus 295, that's 869 people here that have used a snowmobile. And so there are 3 possible values for snowmobile usage, and here they are. 1, 2, 3. Is it still a two-way table? Now we learned that a two-way table is a representation of 2 variables in a table. So how many are there here? You might be tempted to say that there's 3 variables, but there's not. There's actually only 2 variables. One variable is snowmobile usage. That's a variable. There are 3 different values that that variable can take on, but this is one variable. The other variable is environmental club status, whether you're in it or not. And this one only has 2 values it can take on, but that's still only 2 variables, snowmobile usage and environmental club status. So yes, this is a two-way table. All right, let's do marginal relative frequency. It's going to give the percent or the proportion of individuals that have a specific value for a category. Okay, and it's only going to tell us about one variable. So we have some example questions here to help us understand it and to see how to calculate it. Question A, what percentage of the school participates in environmental club and what proportion does not? Okay, we know how many students are in the school, so this is pretty easy. So in environmental club, how many people are in environmental club? 1,221 out of the 1,526 people in the school. 1,221 divide 1,526. The marginal relative frequency for that is, I guess I'm going to round it, that is 80%. Or you could write it as 0.8. Okay, and what proportion does not? That's going to be the other part. Well, if that's 80%, this has to be 20. Now, if you want to calculate it out, that's fine, the way I did right here. But you don't have to. You know they have to add up to 100% because you're either in environmental club or you're not. Now, part B, determine the marginal relative frequency for each value of snowmobile usage. Well, there's 3 different values. So there is never, and how many people never used a snowmobile? 657. So that's 657 out of the total 1,526. So 657 divided by 1,526. That is 0.43. 43% have never used a snowmobile. What about the ones who have rented? Same exact process, but now it's 574 out of 1,526 still. And that is 0.376. And then there are some people who own. And that would be still out of 1,526. But the people who own a snowmobile, that's 295 people. So not so many, which kind of makes sense. Snowmobiles do cost money, of course. 0.193 is what I get for that. Now, because I rounded, they don't add up exactly to 1, but if I didn't round them, then they would. Okay, so that is all that marginal relative frequency is. It's just giving you information about what proportion of people fall into each value of one variable. Here the variable was snowmobile usage. Okay. All right. Let's do joint relative frequency now. What does joint relative frequency do? It gives the percent or proportion of individuals that have a specific value for a category and for another variable. This is different than marginal because it's going to give us information about two variables. That's what they mean by joint. It means more than one thing at once. So here's some examples. What percentage of students own a snowmobile and are in environmental club? So they're talking about how many students fall into both of these categories. So let's go back to our chart and find the students who own a snowmobile and are in environmental club. Own and are in environmental club is right here. So that's 279 out of 1526. So 279 out of 1526, and they asked for a percentage, so I'm not going to write it as a probability, I'm going to write it out as a percentage. And that would be 18.3%. All right, part B, what proportion of students are not in environmental club and don't own a snowmobile? All right, that sounds a little more involved. Let's go look. Not an environmental club and don't own a snowmobile. So who are those people in this chart? Not an environmental club and don't own. Not an environmental club, they've never used, they don't own. If they rent, they don't own. So these are the folks that fall into that category. So what we're going to do is we're going to add those two together. So 212 plus 77 is 289. So there are 289 people in this category. So this is 289 out of 1,526. And that is 18.9%. They asked for proportion, so I'm going to write it as 0.189. And that's joint relative frequency. One thing I want you to get is, even if the names sound a little bit involved, when we see the questions, it's not that hard to go pick out the information out of a chart. Conditional relative frequency works the exact same way that conditional probability worked when you learned about it either in algebra or in pre-calculus. It's just going to tell us what proportion of individuals with one value in a variable fall into a different value in another variable. Okay, so here's two questions to help kind of put that together. What proportion of environmental club members also own a snowmobile? So this question is asking about the people in environmental club. So how many people are in environmental club? Let's look. There are 1,221 in environmental club. So our denominator now is going to be 1,221. Second question, what percentage of snowmobile renters? Okay, so that's a different group we're talking about. So let's go back to A. What proportion of environmental club members own a snowmobile? So of these 1,221, how many of them own a snowmobile? 279 of them. So this is 279 out of 1,221. They asked for a proportion, not a percentage. That's 0.229. Part B. What percentage of snowmobile renters, pause, how many snowmobile renters are there? Rents a snowmobile, 574. So the denominator here is 574. Are not an environmental club. So out of those 574, let's go find how many are not in the environmental club. So 574, not an environmental club is 77. So that is 77 divided by 574. That is, and they asked for percentage, that is 13.4%. So notice in a conditional probability or a conditional relative frequency, which work the same way, what's changing is the denominator. The beginning of our question tells us what group we're looking at, and that defines the denominator of the fraction. When we talk about the association between variables, what we're really asking is if knowing the value of one of the variables is helpful in knowing the value of another. For example, if I know that someone, or if I know that a group of people identify as Republicans or Democrats, I can get some information about how they're likely to vote in the next election. And it's not a guarantee, and it's not a guarantee for individuals, but if a different group votes in a different way, there is an association, in this example, between your political party that you associate with and the way you're going to vote. Okay, so what about for this one? Is there an association between being an environmental club and snowmobile usage? What that's really asking is, if we know about one of those variables, does it give us more information about the other? Or if we know if a person is in one of those groups or the other, can we make some predictions about them? The easiest way to understand how to answer this is to go back and look at the graphs. So let's go back to those. Because what these graphs do is they really clearly show us, based on if they are an environmental club or not, how many of those people, or what percentage of people, fall into each of these categories for snowmobile usage. So I'm going to look at the one on the right. That's easier for me to see, but if you want to look at the left, that's fine. So when I look at this, if I see here that someone is in environmental club, I notice right away that if you're in this group, then your blue bar is bigger than the non-environmental club group, and the green bar is smaller. So you see how if I know that someone is an environmental club, I can see they're much more likely to have never used a snowmobile. So that means there is an association, because knowing this information leads me to more information. And I also know that if someone is an environmental club, it's much less likely that they own a snowmobile. So that's an association. Well, what would these graphs look like if there was no association at all? Well, the two graphs, or the two sides, would have to look exactly the same. If, whether I was looking at the no environmental club or the yes environmental club, if all the proportions were the same, then knowing about environmental club would not help me make a prediction about whether they have never used a snowmobile, rented, or owned. So that's what we would see if there was no association at all. Now, I do want to say that association is different than causation. Okay, and people get this messed up sometimes, or they get it mixed up, sometimes without realizing it. We will accidentally think that something has a causal relationship, like one thing, like being an environmental club causes you to not own a snowmobile, and that is not necessarily the case from what we see here. So please be aware of that, that this is not saying that one caused the other, it's just saying that there is definitely some relationship between the two. That's all for our first lesson. I hope you enjoyed it, and I will see you next time.